Good morning, and welcome to week 5 of Remote Sensing 1, Geography 243, Winter Term 2020. There's quite a bit going on this week and next week, but first let's take a look at last week. Last week we were working through finishing Activity 2. The Activity 2 should be in today by around 6 p.m., I believe, so I hope everybody's doing okay with that. Make sure you take advantage of all the resources that we have, certainly all the video resources. Make sure you're all looking at the content every week. I'm actually seeing that a number of people, are not looking at the content or looking at it very briefly. We can see those sorts of things with D2L. So, please do take a look at the content. The content's important, and it becomes more and more important, I guess, as the term goes along, as these things do. So we did finish Activity 2, or we're finishing Activity 2, as I said, and then going on to some other things this week. We also had this quick tour of a few different gateways. These are mostly gateways for some of the things that we're already looking at, but there's actually quite a lot in there. Take a look at that. These are things that you want to be aware of going forward, of what is there. And these are really probably the most important gateways that we'll use in remote sensing. The three different portals that we looked at last week. This week coming up, week 5, right now, we have some content on georeferencing. Georeferencing, still a very important technique and skill to be able to apply in our work for a number of reasons. Mainly now because a lot of the things that we may want to use in remote sensing, a lot of the data or imagery, maybe as analog imagery, hard copy imagery, or what have you, and it's not georeferenced. And so, and there may even be scanned imagery, digital imagery, that's not georeferenced. There may actually be imagery that is collected as digital imagery. It's not scanned from analog digital imagery. That's not georeferenced. So we need to have some skills that will allow us. It's very likely or possible, certainly, that we'll come into a situation where we need to have these skills to be able to georeference imagery to a map or to a coordinate system that is going to allow us to work with this in a GIS context. And so I go through a couple of different methods for doing this. With the examples that I'm using are digital imagery that's been scanned. It's available in the public domain. And the stuff that we're looking at this week comes from the Illinois Geospatial Clearinghouse, which is in Champaign at the University of Illinois. There's some really extremely valuable imagery that's available through the Illinois Geospatial Clearinghouse of the entire state of Illinois from, I think it's a period between 1937 and 1941 or something like that. So right from the depths of the Depression, just before World War II, and then actually getting up into the beginning of World War II historically. And this imagery, covers the entire state of Illinois. It actually, we got to a point in the 1980s where there was just one copy of this available, and it was a hard copy. It was in the National Archives, hard copy of aerial photographs, just big stacks of aerial photographs. And these were scanned. Fortunately, they're continuing to be used, apparently, by people who are looking at them in the archives. And so they're being damaged by people in the archives regularly. And so the scanned imagery is very important because it's it's very high resolution, not georeferenced yet. And so the examples I'm using are taking these data and georeferencing them using a tool that actually is better. I think it's certainly easier to use than the tools that are in ArcGIS, and that's using Google Earth for georeferencing and creating KMZ files that can be viewed in Google Earth, and it gives you a lot of kind of cool tools that we can use in Google Earth. Google Earth is a pretty amazing browser. That's what it is. It's a browser, and it's a special browser because it's a browser for browsing geospatial data, digital geospatial data, and in 3 dimensions. And so it's it's really a wonderful tool that Google makes available for us to be able to view certainly beautiful images of the Earth, but also in 3-dimensional images of the Earth, but also to incorporate our own data into that browser and to be able to publish data, much as you can publish data on the World Wide Web that can be viewed in other kinds of browsers. But this is a special browser because it's spatial, right? So we do have that going on this week. We also have our Quiz 1 that happens on Friday. That's February 7th, okay? This Friday. And our quizzes are online quizzes. They take place from midnight to midnight. So it'll be midnight Thursday night, tomorrow night, midnight till midnight Friday night. So sometime in that 24 roughly hour period, you need to schedule some time up to as long as an hour and a half, I think, to complete this, up to 90 minutes. I don't think anybody will really take that long to complete it, but up to around 90 minutes. And that quiz, let's see, let's take a quick look at it. The quiz is, here's just that brief summary right there, and as I say, it has around 90 minutes, a 90-minute window that you have to complete that. So we have that going on Friday. Don't forget about it. Put it on your calendar right now. Set an alarm on your phone, to go off at some time. I don't know, whenever. Certainly at a time that you're going to be able to sit down at a computer and complete this quiz. And then I'm also publishing our final project document now, and I want to get this out there so you guys can read it over. Some of the things that I'm expecting people to be using in the final project, we're not even to those yet. So this is kind of what we get in a 10-week term. We start out as beginners and we end up as experts in 10 weeks' time. So some of the things that we're going to be doing in our final project are we've already done one of these now, or we're just finishing up doing this density slicing or level analysis, where we're taking a small segment of a digital image that we have special interest in, and we're classifying that. We're taking it and classifying it into tiny little bits that not in the computer sense of bits, but into tiny little sections that we have. We are taking information and interpreting information and evaluating information from the digital image in order to apply intelligence to this scene, to give it more value, right? So we've density slicing. This is the first technique, and this is a special form of classification. Next week we're going to be doing image classification. I'll talk about that in a second, but this is another thing that I think some people will be using in the final project. And finally, change analysis, where we do temporal image differencing, the differences between images, tightly georeferenced images. Okay, very, very cool and very powerful technique. Image classification that we're using in the final project. This is something we're going to be taking a look at next week, and we're also going to be starting activity 3 next week. And just think about it for a second. Image classification. You guys have been working with Landsat 8 images already, right? And so Landsat 8 has really 10 or so channels. It depends. Like there are special channels in there. Channel 9, for instance, really is looking at the atmosphere, and it's using the data of atmospheric irradiance to do atmospheric corrections on the imagery before we get it on a pixel by pixel basis. Really an amazing improvement with Landsat 8. It gives us much higher quality images. However, we have let's say we have 9 effective channels. That's assuming that you only use one of the thermal channels. If if we had 10, then we'd be talking about a different number here, because I'm going to show you a number in just a second that is a ginormous number. Okay, so in each pixel in a Landsat 8 scene, if we have 9 channels, then we have 144 bits of data, 144 bits. And we all know what a bit is. A bit is a little piece of information that's either a 0 or a 1, right? There's 2 possibilities in each bit. And so with 16 bits per channel and 9 channels, we have 144 bits of information that we're collecting every 16 days for every 30 meter by 30 meter pixel on Earth, on the ground, on the land area, and I'm not even counting the ocean, right? So we have 144 bits of information that we're collecting in each 30 meter pixel. Okay, so how much information is that in each pixel? How much information is that? Well, in fact, it's quite a lot. It's 2 to the 144th. This is the best way to think of this. It's 2 to the 144th power. So 2 times 2 times 2 and so on, right? Out to 144 times. How big a number is that? How many possible values, integer values, are there in that pixel? Like how many different possible values can you get with 144 bits? How many? Here's the number. This number here times 10 to the 43rd power. Okay, that's 10 with 43 zeros out there to the right of the 1, right? Times this number, this large decimal number here. So it's a really ginormous number. I don't even want to try to say, I have no idea how you would even say that number other than reading this off and then giving its exponent here, right? So, this is a ginormous number. How big is it? Well, we did this calculation at one point in an earlier version of this class, where how many pixels are there on Earth? There's a lot. It's a very large number, okay? Just the land area pixels. If you look at all the land area and you divide that by 900 square meters, 30 meters by 30 meters, there's 900 square meters in every pixel, right? So we could image every pixel on the land area of Earth until every 16 days. We could do this until the sun burns out, goes supernova, shrinks to a white dwarf, or whether, the astrophysicists can tell us what is going to happen, but until the sun goes supernova and everything ends in this solar system, right? We could image the Earth every 16 days and never repeat a value in any of those pixels. And on any of those millions and millions of images every 16 days, which is billions of years out there, thankfully for us, right? We could do that and never repeat a single value. Theoretically. Now, we probably are going to repeat some values here, but Theoretically, we could do that without ever repeating a single value. Mathematically, that is possible. So that's the problem we have to solve with image classification. We have to take these huge numbers, ginormous number of possible values, and reduce it to a really small workable number, like 12, 13. And we'll call those things like forest, grassland, several classes of urban, residential, industrial, commercial. This is the problem we're solving with image classification. Very powerful tool. So we train our system to identify pixels, to take those ginormous numbers, those 144-bit numbers, and reduce that number to a possibility of like a dozen or so. It's a very powerful, believe me, it's a very powerful tool. That's what we're doing next week, okay, in week 6. This is week 5. There's a lot going on. Don't forget. Quiz 1. Don't forget the content on Geo Referencing. And the final project document, which has been posted now. Don't forget, okay? Do these things.